Hey, so last time things have changed since the last time, haven't they?
Very much, yes.
15.1 or 2 million.
Most of it, correct.
So, man, very different story. So, yeah. So the deal flow right now. So lots of people applying actually. So I mean, deal flow. Like I've got over 100 messages. There's many, good number about inquiring about the apprenticeship and all that. So, man, it's a different story.
Very glad
So,
to hear about it. You have
yeah,
some company into this whole adventure.
yeah. It's good. Canada is insane here. Yeah, the guy Joshua Pierce. Oh, he is hardcore open source. We're talking about OSC Canada and other things. The collaborations with him. I mean, yeah, we got into a lot of relevant topics. So looks really good. I mean, we're actually going to the point of looking. I think we might have to get some land here and actually start a parallel operation. I mean, so I'm a visiting professor at the school, and with his contacts and insight into local community, Western University, and some other things, it'll be interesting. So let's see what happens.
Very excited about it. So we have North America covered. You can see from Mexico to Canada. And of
Yeah,
course,
and you know the funny thing that happened actually. So Canada is canning immigration, just like the U.S. It's getting really hard, and so what Joshua Pierce is doing, most of his students are actually from a lot of different like Bangladesh, Togo, lots of different international locations. Hardcore open source warriors. He's got about 20 people in his group. Um, Now, the one thing that I do notice, a lot of the people applying for the apprenticeship, it's about foreigners, which is good. I mean, there's a lot of hungry people outside the U.S. I think I told you that the U.S. people are just not hungry enough right now, right? Um, so one strategy is to pursue, like, open it up to the globe. For that, we need the ability to take in immigrants, and with that, I mean, we could. I think that's a strategic approach, like high quality people from countries in low resource environments. I think, you know, and that actually that the funny thing is that if Canada and U.S. are out because of immigration, that leaves Mexico. Huh.
correct. For now, I mean, we don't have any pressure, and I don't believe it's the structure of the Mexican government pressure on immigration laws. So if we're talking about the makerspace that could unite us all, maybe this could be a nice location.
Yeah. Um, should we get some land there?
I do own some land, so probably it's going to be easy for us.
How do we do that?
I would say depends exactly what you're looking for, but here we have a lot of available land. It depends on the what you want from it, type, structure, size, availability of water, energy, all of that. It's easy to get.
Um, if I wanted to get 100 acres, what would that cost?
As of now, and we're talking with no access to water. I'm just talking about agricultural land. It's I would say 300,000 pesos, and we do that by 20 Mexican pesos to USD. So that would be about 15,000 USD per hectare. Let's do the conversion to acres
You saying 300,000 pesos?
per hectare. For a full hectare, 10,000 square meters.
Yeah. So about 15,000 per hectare.
Correct. Now let's divide that just to put it in acres, and there we can find the calculation we're looking for.
Hmm. Hmm. Are you affiliated with any schools? Can we get accreditation there soon? Because for that, like, I imagine that if we're gonna invite people to Mexico, um, Yeah, the economics are different there. Housing, would housing enterprises work like similar to what we do?
Yes, and I was researching the cost of materials, and I believe I haven't really checked component by component, but it could be about 60% cheaper here because of the cost of materials and labor. I mean, it's not a plan to pay like low wage, but I'm just doing structuring the cost output we could get here on the actual conditions versus what you can get into the US. I'm not really sure about Canada wages, but that's the difference that we get here, not just on wages, on labor. I'm talking about cost of materials as well, steel, wood, even plastics. If we go into a recycling structure, all of this change a lot in the cost here.
Yeah. Huh.
And about the school's affiliation, directly as of now, I'm not involved, but it would be I would say, a plan to mention we need this, we're gonna make this, and then start connecting with the right people.
Are there is there a number of schools or universities, tech schools nearby?
Yes, I would say big ones, at least five in my city, which is small. It's seat about 300,000 humans, so it's not that big, not that small.
Yeah. Huh. That's
At least
compelling.
big ones that have structure that you mentioned, asking for some support advice to be able to access certain amount of land. And in that case, if we put it in an education structure, there are some opportunities like grants that where we don't have to even buy the land. We can take like not even a lease, just being able to use it and put it into a education structure.
From who?
Well, you could correlate to governments, but you also could relate to universities that have land access.
Okay. Sorry, let me get my notebook real quick. Or no, I'm just gonna take notes here. Um, yeah, yeah, yeah. Huh. Interesting. I think we might want to let the dust settle on what happens in after this trip, and see what we want to do about it. What my mind is like after we talked, it was and now and actually quite encouraged. Like for example, there's a person signed up today for the Builder Crash Course, signed up yesterday. It's like okay, so deal flow, amazing, right? Um, with all of that, let's see where we stand at the end of the week. It's last time it was the being kind of in a desperate situation when before the flood hit. It was it made me think. Okay, yes, I'm soul searching. Like how do we crack this personnel search, right? Um, one thing on my mind right now is third world, high quality people. Third world or not American. Like they're lazy. They're not hungry anymore, right? Um, much much harder to get that kind of interest. Like, for example, in Dr. Pierce's group, some people, like the person from India, it's like, oh yeah, they're working on solar because they actually still burn candles back at home. So they've got like real needs and stuff like that. Um, so yeah, that's kind of where I'm thinking. Do you have any new thoughts on that, or so the document that you're sending to me? Okay, what would you like to do? What would you like to do? Talk about today?
I would say your current approach, like third world hungry people, is the best way to go. I mean, the groups
Mm,
I sent to you, they are basically elite groups that they have solved the economic part of their life, and now they're trying to get together with people to make some social impact. But I don't see that type of persona just going into hands-on into structuring a house, structuring a tractor. I believe they are most PR people, and also social beings that like to talk about how they're going to change the future with their money, but not exactly their hands. That's my approach. And when you
yeah.
told me about it, I just got it and say, okay, it's cool to be connected with these successful people, but they're not going to be the hands-on makers to start making the open source change.
Yeah. Yeah.
Europe is the best for now.
Yeah. Okay. So you agree on the approach of the hungry people?
For sure,
Mm-hmm.
and hands-on most of it. People can be hungry for social change, but if they don't put their hands into the work and making the time for making the first step, it's not going to happen now. It's not just a money thing, it's a hands-on thing.
Yeah, I agree with you completely on that. Yeah, yeah, yeah. Especially after I've seen some of these people in Dr. Pierce's group. Yeah, they're different kind of a motivation. Um, it's actually very refreshing because I mean they're all pretty much abundance thinking individuals. So it's really refreshing to see some of the people here. Let's see what happens. Like if nothing comes up right now, my thinking is if there's no realistic possibility to make that kind of a thing happen where we're guaranteed bodies around here, and primarily because of the immigration crisis, we should be talking seriously about going down to Mexico.
Yes, that's a possibility, but
Yeah.
I don't want to talk. If the group doesn't gather now, I still believe that we can keep working together into
Yes.
this. I will start making things, and when I start making a huge impact on savings, quality, lifestyle, life cycle design, all the rest is going to come together.
Yeah, yeah. Still agreed. Still agreed. Okay, so let's talk about it. Let's. You want me to look at the doc that you sent?
Yes, that's the spreadsheet that I've been working.
Mm-hmm.
So some of the components or concepts, I was able to make them per plant, which that's a lot of clarity to view the business model. But I haven't finished all of it. Not because I didn't have time, but because I want to talk with you these ideas.
Okay.
If you open the document, please let me know if you open it already.
I opened it.
Okay, as an example, I'm on where it says USD in process. It's the
Okay.
first.
Yep.
The
Go
first.
ahead.
I don't know how it's called in English.
First tab.
First step, correct. And on C62, you're gonna start seeing the capex
Okay.
in
Capex.
USD
Mm-hmm.
per unit. Last time we talked about making everything per unit, not hectares, talking about per plant. So in here, I started making calculations and I was able to get the cost in USD per unit. In this case, each pot it's 0.35 USD. Each base is 0.50. The grow media, what we use here is coconut coir, and we put 35 liters per plant. So I did the calculation of the 35 liters of coconut coir, and into this cost, it's included the cost of logistics. So the suppliers have the cost of the unit, let's say the cocoa coir liter per liter, but they also have to send about, as an example, 20,000 packs of cocoa coir, and I made that calculations to include the logistics from the supplier and also the cost of the material. And then I did the number of units needed to get for one plant. And as this case, I'm repeating, it's 35 liters of coconut coir into a single pot to be able to plant one single blueberry plant.
Mm-hmm.
That's why the calculation is made that way.
Mm-hmm.
And then I went into a ground cover per plant. In this case, what I did is that plant distance we use per plant. As an example, we do 0.7 meters. That's the distance in line per plant. And we do 2.7 meters. That's the distance between rows per plant. So what I did is, as an example, it's 0.7 multiplied by 2.7. That's 1.89 square meters. I took the cost of 1 square meter of ground cover, and then I multiply by 1.89. That's what I meant. That's the cost per unit per plant of ground cover. That's how I made the calculations.
1.89 is the unit of ground cover per square meter.
1.89 square meters per plant. That's what it takes of ground cover to, if we put just a single pot of blueberry, we would have to make an area of 1.89
Mm-hmm.
ground cover. Then I went into this last part where I want to have some ideas with you. On the irrigation system per plant, if you take the full cost, and I'm talking about, can you let me share a document?
Yes.
It's in Spanish, but you're going to see some images that they're going to be very clear of what I'm talking about.
Yeah. How'd I do that?
Well, if you want to go to irrigation system cost structure tab, which is next to USD in process, and then on cell B2, sorry, no, B1, you're going to find the document. This was a quote I got of 40 hectares of irrigation system. If you open it, let me know when it's open.
It's open.
All right.
It's open.
Okay. Here you're gonna see the design, the layout of the different sections, and also how much liters per drip line, per pump. But what I'm trying to explain here is, yes, I did find that 3 point something is the cost per plant. But if I want to start now with a single plant, I have to buy many things, many components to make this happen. So as you can see on the images,
3.8 per plant, right?
yeah, but that's taking a 40 hectares quote, structuring all the components, and then putting per hectare, and then putting 5,100 plants per hectare, and that's how I got the final 3.8. What I mean by this, it's not modular.
Yeah.
It has to have some big purchases in order to be able to get this and economies of scale. So in the document, you're going to see different images about all the components it requires. Even the reservoir is included. And what I'm trying to get here is, how can I take all this information and make it something smaller to be able to say, I need to buy at least this amount of components in order to be able to irrigate this amount of plants, because this 3 point something per plant is already included with the whole system for 40 hectares of production. And that's including the computer controller, the pipes, the automating components that it has the system, a big reservoir, also some fertilizer automated controllers, some software to be able to identify how much water has each pot on the cocoa car, the drainage system that is for being able to identify how much drainage per plant you're getting, and with that specific data, just as an extra note, you can verify how much water does really your plant need, because you measure drainage, you measure how many liters of water you put into that plant, and that's when you do some adjusting of the water. And there's also a sulfur burner, which is basically a chemical component to be able to lower your pH of water, since blueberries thrive being pH 5 to 5.5, and usually water, at least in the north part of Mexico, it's at least of 7 to 7.5. So this is macro concepts. How would I start structuring in a modular way to be able to make it with less amount of investment? If we see here the total cost, if you go to the last slides, I would say from last, go 4 back. You're going to see the control cost table, and you see the whole import in USD for 40 hectares. We're talking about 770,000. So
Where's
that's for
770,000? I see 236 million, 236,000 million.
are you in where it says cost table? Well, it's in Spanish, but tabla de costos.
Superficie de cultivo.
Uh,
That. Oh, so, yeah, tabla de costos.
yeah, so I went into importe dolarizado, which is basically they unified the Mexican pesos and the US dollars. They do the conversion rate of Mexican pesos to US dollars, and they put the whole output in US dollars, which is the 770,000 US dollars for the full project. We're talking the irrigation controller, the tubes, the automation stuff, the fertilization automation, and the reservoir included, and the installation of labor. That's the whole concept. But I want to be able to take and make it smaller in order to make it more feasible.
Yeah. So they're costing about 19,000 per USD per hectare.
And that's what I got. I say the 19,262 US dollars. Then in the plan design, I'm thinking it's 0.7 inline and 2.7 between rows. So that gives us in each hectare 5,100. That's how I got the 3.7 USD per plant. But it's a very big ticket to be able to get that 3.7 per plant.
Yeah, yeah. Okay.
How should I analyze in your perspective this? That's why I stopped here and I wanted to find a modular solution.
Yeah. Okay. So let's talk about how do we modularize it. Okay. So first of all, we're going at irrigation system at $3.8 per plant, and so we're leaving the second biggest one, which is cocoa coir, at about $2. Like, we're not worried about that for now.
Yes, for sure, because that's one of the biggest costs.
Um, what would you like me to do today? So let's start talking about how do we modularize the $3.8 so it's really $3.8 at the minimum scale. We're paying $3.8 for a microsystem, right?
Correct.
Yeah.
I would say let's start with water, since water is the first step of everything.
Yeah, yeah. So the ponds. So I'm looking at, okay, if we think about it, we got ponds. Wait, the irrigation system includes nothing of the pots, right? It's the irrigation system is currently separate of pots. Is that correct?
That's correct, most of it, but some of the drip lines, they are specifically designed for pots. What I mean by this is that the length of the drip line has to be measured to be inside the pot. So that's how you do, as an example, if we're having plants that are in line 0.7 meters, we want to have a structure of the line to be 20 centimeters by 20 centimeters, that's square centimeters, to have drippers, and then 50 centimeters of that drip line to don't have drippers, because we don't want to waste water outside that transition. That's what I meant.
Mm-hmm. Mm-hmm. Yeah. So you've got a detailed price breakdown, so we can start talking about, let's just start going through details. Yeah.
Okay.
Am I seeing from page number? I want to find out the detail of how each one is being fed. You've got this drip line going into each pot from each tube. from the tube, you've got to break into the white tubes. You've got a drip emitter into each pot. Is that how it works?
Yes, on assigning the plant distance and the dripper distance, that's correct.
Yeah. Naive thinking is like, okay, we're going to talk about like 3D printing that. Does it save us any cost? Let's take a look at what are the real costs. The
Earthworks, for sure. If you want to make a big reservoir, you're going to need machinery operated to be able to make the excavation on a measured way.
Yep.
And then print plastic. That could be another good use. So you can hold the water in that excavation. That's an example of the reservoir. If we're talking plastics, we're talking about the tubes. That's another big cost. Different size of tubes for the water transportation.
This system does not include the desalination?
No, not this system. Not this cost. I have another file on that same document, but it's of a small scale. I would like to take this, and put it the reverse osmosis to be aligned with this amount of water of 40 hectares to have a same structure.
Okay. Let's go into the working dock and we can let's see, where's the Blueberry dock?
Let me put it on the chat.
Oh yeah, so it's open source Blueberry production conceptual design. Okay. Why don't you go into that dock and let's just start breaking down. So the idea is, when approaching any problem, modular breakdown is the magic. You can break it down into the smallest parts. You've got it. You've got the details here. We can now take each single component, start analyzing it, but we want to take it, of course, by the components that are the most expensive. So how about we use this method where we let's take the top three. Let's start, put a separate page on a document.
Yep.
Now the document I see you, okay, so let's go to the very top, page 1. Give me a new page, and let's start breaking it down. We can work by, and put that on the very top so you don't get lost at the end of the day. Let's draw little bubbles. Let's say these little things, and we say, what are the top three? Reservoir?
Reservoir.
Mm-hmm.
I'm just going to open the document.
Yep, so I'll have the document in another tab, and I'm going to look into that. We've got dollars per hectare. What's regante sistema uno? What is that?
It's divided by two systems, by two sections. That's why they call Sistema Uno.
System 1 and System 2, okay. So now you got to look at the things above that. And what's the breakdown to the two sections? Oh, section 1, okay. 40 hectares, but it's got two big sections?
Correct, 20 hectares per section.
Does each section have a pond?
Yes.
Okay. Tanque. Which line is the Tubera valvulas Tubera medidor tanque? Is the first item where's the reservoir? Is that the line item 1? Dos equipos de bombeo. So
That's
pump
that's
equipment.
pumps.
Where's the tank? Where's the reservoir?
I'm looking for it's excavación y relleno zanja. That would be the last concept.
Oh, excavación. Relleno
That's
de zanja. What's relleno?
filling. Filling of
Okay, and filling. And
soil.
zanja, the soil.
If we go of the
Mhm.
most expensive, I would say it's the automated fertilization. That's 111,000.
Oh, good.
So that's easy to open source, I guess.
Oh, yeah. Con What's the conducción? That means plumbing?
Yes, it's where the water flows. Plumbing, correct.
So what's the first plumbing versus the second plumbing line? Carcamo.
Carcamo is the concept where you access the water. It's like the storage of water. It's a small excavation where the water holds there, and then the pumping system absorbs it.
Ah, there's a little like a wait. Is there a picture of that? A pit, like the suction pit?
Correct.
Do we have
Probably.
a picture? Where is that suction pit? Oh, is that the thing on the reservoir slide? It's the fourth picture. Is that the suction? No, the thing inside the concrete. What's the concrete for there?
Concrete, which where is it?
On slide number 1, 2, 3, 4, 5. What's the concrete? The plumbing inside the concrete weighs.
Got it. It's just for fitting the tubes of the pipe, and it's like a safety space. If you drop any fertilizers, like acid, they can go there.
So that's the pit we're talking about.
Not really.
Is that pit in the picture before like by the blue tank? No. Can you show me an example of what that pit looks? It looks like you're sucking directly from the big reservoir. Is that the case?
In this case, it is correct.
But that's not what the quote says?
Well, yeah, it's the exact code of these exact pictures. All is related in this presentation.
Uh-huh. Okay, so if we go back to our working doc, the number 1, what's the mano de obra?
Labor.
Mano de obra. Oh, okay. Hands of the work. Okay.
Correct. So number 1 would be labor with a concept of 114,000.
Mm-hmm. 114,000. All the labor above, right? Everything.
Of everything, yes. Then it's the automated fertilization system with 111,000 as a second concept.
Mm-hmm.
Then this is called regante sistema with 89,000, sorry. And that's.
But break it down. We have to break that down, right? So you're not going to say that. We're going to say which component of that is the biggest, right?
Yes, that's what I'm trying to find. Honestly, as of now, I haven't identified, but I will.
Okay, so
Those three, I would say, labor, automation of fertilizers, and I would have to find out which is regante sistema. Those are the three biggest concepts of cost.
Okay, so I'm saying labor, automation, and when we say automation, it's automation of fertilization,
Yes,
and all the other automation like valves and so basically all the controls outside of fertilization, that's the third highest.
yes.
Fourth highest is the digging, right?
The reservoir, yes, but it's the earthworks, not exactly the plastic.
Earthworks, yeah. Just earthworks minus plastic?
Yes,
That's a lot. Holy cow.
yeah, they
Uh,
charge a lot.
45,000. What's the size of that reservoir? 1 acre
I,
about.
I would have to ask about the amount of total liters and size in acres. I will put it here on the working document.
Mm-hmm. They don't say that anywhere, do they?
They don't say much.
Mm-hmm. Okay. All right. So we got reservoir is number 3. Wait, no, that was 4, right? No,
Yes, for
4. Three is auto controls and 4 is reservoir. Yeah.
the excavation for reservoir. Yeah, would be number 4.
So
I'm not sure where the plastic
earthworks.
is.
This is cool because auto controls. So I'm here at with Dr. Pierce, and he's good on auto controls. He's got a lot of stuff on that. So they're doing these universal controllers that are highly relevant to what we're doing here. They're doing, interestingly, just one idea that. Have you ever heard of agrivoltaics?
Yes, about the solar panels into
Yeah,
agricultural land.
yeah. Um, we should take a look at the numbers, but the idea there is that you're producing power and shading, because I mean that's relevant to shading. If the cost of those panels were low enough, we should actually consider that if it's worth investing into power production along with shading in one, because that's the case for the agrivoltaics. You're creating a better environment, but you're also manufacturing electricity. In fact, that's your solution for part of the netting. Possibly for part of the bird protection or shade protection.
Yeah,
So
sunshade.
yeah, sunshade. Um, that's actually good because you need electricity. Because I think the assumption here is you're not going to be running this off the grid electricity. You're going to be running this solar, no?
That's the plan, correct.
Yeah, absolutely. He told me so Dr. Pierce told me some crazy news. In Canada, you can get solar. I told you 20 cents per watt. He says it's 7.5 cents for a container. Holy shit!
That,
I mean, that's
yes,
like,
yes,
I mean, that's like 3 times lower than what I told you, and what I told you already was almost free. So I think there's going to be a strong case for agrivoltaics. Um, So they're doing a lot of these experiments here at agrivoltaics. Like they're actually talking about climate change. How do you modify the environment for the plants with climate change? They're future proofing. And today I appreciated it for the fact that, okay, well, because they showed various plants that under shade they actually do much better than out getting dehydrated, right? Um, and for climate survival, that could be critical in the sense that like a shock that would actually kill the plant if you shade it, it won't. We actually have a huge control over the environment, which actually made me think about our land. If we do that, there's going to be things growing that can't grow at this time, which is interesting. I start to appreciate that. So that's good. Into this, we definitely are going to want to calculate what the shading fraction is, and like what we can substitute with agrivoltaics, with the photovoltaic panels that are producing electricity, and how to hang them. So now, yeah, so they do a lot of work here about how you hang the solar panels. One way to do it is wood, pressure treated wood. I think it's probably what we want to do. They're actually saying, oh yeah, actually the wood is for Canada here. Wood is the cheapest option for mounting PVs, and maybe in Mexico. Do you have a price for a 2x4x8 from Home Depot? What's it cost?
No.
Can you Google it real quick? Home
Yeah.
Depot 2x4x8. In the U.S., in Canada, it's $2.75.
I'm doing that right now.
Yeah, let's do that. Yeah, this is interesting. Like when I visited their farm with agrivoltaics today. It's pretty sweet, actually. Um,
2x4x8
yep.
on Home Depot would be 215 pesos.
Divided by.
I do 20. I know right now maybe lower, but would be 10 USD.
Holy cow, that's a lot. What? Your lumber is 3 times more expensive than Canada.
Let me, well, it says imported, sorry. I'll look at the local one.
Because we wouldn't be able to use wood, because we have to look at other materials.
I'm just gonna paste it on the
Yeah.
Google Meet. Maybe I'm looking at the wrong type.
Yeah. Before we go any further, for next time, what I'll do, can you actually, I wanted to give you a Eduardo at opensourceecology.org account so that
Yes.
you can use the Google Drive that, in case you disappear, like everyone on those 15 million messages tells about me, this work won't. Did you see
Sure.
that? Did you see that? How ridiculous people think? Like, there's a lot of they're like, stay safe. The CIA, the man's gonna get you. I find it entertaining.
I saw that. Yeah.
But it's funny that's a thing that a lot of people do. They actually believe that? Yeah, it sounds like they do. So it's one of those inaccurate mental models that are propagated through society. Yeah.
Sure. Let's do about the email account.
Yep.
Let me know where I can get it.
Yeah.
And I start working
I-
from there.
I'll do that for next time. Let's not do the time. But I was just thinking about that. We'll do that for next time. Okay. So if we go to labor, well, earthworks. I can tell you about the earthworks. I mean, man, we should. What is the total price of the earthworks? You've got that as $45,000.
Yes.
Okay. So on one side is like, okay, actually I think we address that automatically if you do the open source skid steer. Yes, but there's a price involved in that. There's a significant cost of the equipment. So once you get that piece of equipment, your marginal cost goes down to like literally zero. But I don't see a way to do it less expensively at this time. I mean, so we're going to need to invest in the machines until we have the ability to make our own metal and parts. We're stuck with a cost of $15,000 to $30,000. I think with the $30,000 for the skid steer, that can dig a smaller pond. If we're talking about a small pond, that's one way to go. If you address the pond digging, if you're investing for the long term, you want to get your own lifetime design equipment. There's possibilities to. Do you have rental ability? Like you can rent this equipment and do it yourself, or?
Correct. Yes, that's what we do on our current projects. We have to rent, and we have different prices on each type of work, like leveling, excavation, and it has different cost on type of work and time of the task work. That's how it's measured here in
Yeah.
place.
Just one note I will make is that if you talk about a reservoir, one way to do it is to dig. The other way to do it is to build up. So you build up walls, which you line. Do we want to consider that?
Yes. So my current reservoirs, they are built up from the ground up. That's another option, and in my perspective, it's much more precise. The idea that we talked last time of doing small reservoirs for each line, I think that would be a magical solution, since we would have to spend much less material building and have more concentration of each line in order to be able to recycle the water. We also talk about being able to reuse the same water of the line. So instead of doing a big reservoir, as we saw in the document, we could develop that idea. Let's say we have a 500-meter line, and at the end of that line, there's this reservoir that can reloop the water that was used on each pot. For me, that would be the best way to do it, instead of making a big reservoir and start moving the water from the big into each line.
Okay. Yeah, I mean that's definitely a way to do it on a very low cost, incrementally. What did you say was the cost of the 55-gallon drums?
What's that on liters? That's
You showed me for a 55-gallon drum. You told, oh yeah, $20. You told me that's on page 5 of the doc. Buried 55-gallon drums.
correct. Yes.
Do you want to do some like in water recycle? Yeah, that one. Let's put it up here. I think that's.
Yes. For me, I think the top thing to do would be a water reloop system. So what we're seeing here on slide 5, the buried 55-gallon drum, and be able to recycle each line water. That's a hit for me, since we would use much less water, much less fertilizer, and if we do that, what would be the point of investing so much on automating everything, like fertilizer, which is one of the biggest costs, could be reduced very much just by this design.
Yep. Okay, I like it. So we're gonna scratch $45,000 from the budget. We're gonna need an auger to dig in those, a 3-foot auger to dig in those 55-gallon drums into the ground, or a 2-foot, like a 30-inch auger. So if we were to look at, I'm really curious about the size of that reservoir, but we can calculate it. Like, let's assume that you said a plant uses about 4 liters a day or so.
Yes, from 4 to 6 when they're adults at max.
Uh-huh. So if we had those 50 plant, the design on page 2 for 50 plants, that's exactly what you want to do for 55-gallon drums, especially when you pump from one side to the next, the receiving reservoir will probably uh, be like whatever the 55 gallons is minus what the plants use up. Um, when you say 4 to 6 liters, is that with a non-recirculating system?
Correct.
Um, is there evidence that is there any evidence of water waste in that? What's the water waste? So you're dripping that into the pot.
30%. What we try to do is the max amount of drainage we're looking for is 30%.
It ends up going out the holes at the bottom.
Correct, and we measured by drainage. We basically put like a big plate, and if we do 6 liters, we have to make sure that only the 30% of those 6 liters are going into the drainage, and the rest is taking up the plant, or at least is keeping it on the cocoa coir. We could do less. I mean, the best would be 10%, but since there are variations, sometimes we go until 30%. So the range of different plants that have a different absorption, it's between 10 and 30% what we do on drainage goal. But 6 liters is what we program the controller and we put into the plant as an example each day.
And did you measure that the how'd you get 30? How'd you measure 30%?
We have the pot, and below we put a big plate, and we put that pot a little upper. We put certain tool. I don't know how to call it in English. If it's on the soil, we just put it a little up, and below we put a plate. And then when it's doing the drainage, the dripping, it comes into this plate.
And you just
and
measure
then
it.
we measure the amount of liters in the plate. That's it.
Okay. So the pots that you're currently going to get are those square ones. Is that correct?
For now, yes. But the best ones would be the ones that can recycle. What I mean is open to change. Both type of pots work.
Let's those have holes at the bottom?
Which ones are you looking at?
The white ones?
Oh yeah, it has holes in the bottom.
Okay.
The ones where it's clear.
How practical is it to get the? Do we want to go to the step of? Well, let's just. The cost of those is not high, but it allows us to do the fittings at the bottom 3D printed, so we build in the irrigation from bottom watering, which is clearly superior, and it's going to get you 0 water waste, right?
Yes, we can change up the type of pot. I'm looking for a picture that I'm gonna post here on the working document, so you can see the other type of pots that are used. It's a harder plastic, more structure, and it could really help on doing the water layer that we're seeing here on the slide. That could do the relooping of the water use.
Go ahead. How would you reloop from the bottom?
How would I do which part from the bottom, sorry?
You're saying that the black pot Wait, are you covering up a slide that's going to be used, or no? No, you're going to just shrink it down.
Yeah, and move it into another slide.
Okay. Um, can I just cut and paste that and move that into
Yes,
that one?
correct.
So, okay, I see it. How are you going to modify that to get the collect the drainage?
This it has the pot,
Mm-hmm.
and below has a base,
Yep.
and then the water goes to waste. The modification in my mind would be, instead of just having a base below, would
Mm-hmm.
be closing that base into a closed cylinder that concentrates water into the drainage
Mm-hmm.
pipe, and the drainage pipe would go back into the reservoir.
So what are you doing? Are you doing this? So here's your pot. Draw me what you're gonna do. Can you draw? Use that multi-line tool, polyline under that, next to the line tool. You see that? So are you saying you're just gonna do a close?
Like a closed cylinder?
Next to the line tool there's a multi-line tool. If you put the down arrow has a polyline tool. You see the polyline tool?
Yep.
So and you're gonna put fittings on the base, so that's a simple modification, something like, yeah,
A single pot would become a single pot that has the integrated, instead of the base,
Yeah.
would be just like a flow of water,
yeah,
a capture of the flow of water, and that
Mhm.
flow of water would concentrate and go directly to the pipe that would be below this, and there would be the cycle of recovering that water and put it back into each single line reservoir that we talk of fitting that $20 kind of cylinder tank.
Yep. Okay. So we have 85 cents that we're working against for pot and base that we can talk about 3D printing that. Do we want to be talking about 3D printing those integrated things, because now that is going to start incorporating the actual water distribution system. Therefore, the price that you're saving per pot is not only the 85, what is that? Yes, 85 cents for pot and base. How much goes? Oh, we need the number for the per plant distribution, so like those pipings and fittings. Because what I'm seeing immediately is, if you 3D print that, you 3D print the pot and base, or an integrated design, and from there you're also printing the tubing that's going to connect it, or for both the one-way and the return, something like that. So that would be an interesting proposition. The question to ask here is, how much are we saving also on the distribution and the forward and return line plumbing?
We'll have that answer for next call for sure.
Mm-hmm.
On current setup, and I believe the quote I uploaded into the spreadsheet, that would be the base reference to take the actual cost and then make a reference on how much would be saved into this new design of relooping water pots. That could be measured. And also I'm thinking about coco coir, which is one of the biggest costs. The reason we put more liters of coco coir is that we have a buffer of water. So in this case, if we have the reloop system, we could really reduce many liters of coco coir, and the cost will reduce.
Oh man, if you have the reservoir at the bottom system, you're saying you're reducing the volume of coco coir? That's what you're saying?
Correct, because the reason we put more coco coir is because we need to have a buffer in case the irrigation system is not working,
Yeah.
electricity is not working.
Plus the pot has a 3D printed integrated cover for evaporation. Okay, so we're covering all of that. Cool. And here's the thing that, so a relevant thing here, they're doing biochar here, Dr. Pierce, integrated with 3D printing filament. And they're talking actually about growing media. We talked about the replacement for cocoa coir. Integrate biochar with plastic, and now you have introduced porosity and microbe habitat into 3D printed filament. We could potentially, if we're, a development point could be actual 3D printed filament that acts as cocoa coir because it's got embedded biochar. That's sexy, right? That's pretty interesting. You see what's happening there? You've got fibrous structure from the, you know what spaghetti is in 3D printing? It's when you lose a print and it prints this hairball of plastic. Have you seen that? Imagine that. Okay, so if you mess up a print, what can happen is the head just keeps going on its regular path, but it's not working, so it just creates something that looks like spaghetti. It's a ball, it's like a ball of hair. And imagine just printing that with biochar embedded filament. I'm suspecting that at the end of the day we could do something like 3D printed cocoa coir replacement, which is plastic plus biochar. That would be interesting, right? You see what I'm saying?
Yes, I mean the reason of the media, we're using cocoa coir because it's what we have access and is the best price, but the media is just for having, let's say, a structure for the root to develop and absorb nutrients. So any type of material, not any, but many type of materials could work on this structure.
Oh man, and actually if you have further control over the pot itself, you're getting into aeroponic territory. You see what I'm saying?
Yes.
Yeah. So I think we're going to get rid of your cocoa coir pretty soon. Anyway.
Yes.
Possibly. Yeah.
That's not my favorite part because you have to buy it, you have to prepare it, you have to put it in the pot. It's too much.
So let's talk about some. So Joshua Pierce here is talking to me about various grants. We're going to add this to our grant list because in Canada, so one thing we did talk about is if we put money to fund, for example, I could spend money through the university, they could double it. So say we pay, like $15K for a student for a whole semester. Like we could get 2 students for a semester for like $15K doing 20 hours a week of dedicated work. So we're basically funding direct OSC research. That's one way to go about. I'll ask Dr. Pierce or Joshua. Let's say I call him Joshua.
Yeah.
Let's ask Joshua what he thinks about it, because he's actually looking right now for a shopping list of items from me that we can write a bunch of grants for, because he's got pretty much clear primacy and access to those kinds of grants. So let's add this to the list. I'll talk to him about it. See what he's done in the growing medium world. But today it was actually yesterday it came up, the cocoa coir replacement through biochar embedded filament, which was wow. This is like they're doing so many things that are so directly relevant to this, from 3D printing to everything else. So let's see where that leads us. Can we quit here?
Sure. You say when it's time to quit. I have many things to research and be ready for next call.
Okay. Let's quit here. I'm gonna bring this up to Dr. Pierce, to Joshua, see what we find out about it, and after this week, we'll see if we have to decide to go to Mexico to get foreign talent. Yeah.
I'll be around for sure. And please, when you have the time, send me that email to start working from there.
Yeah.
And we can upload directly everything to the satellite that you mentioned before.
Yep. So in case if you are endangered, we're going to save humanity from loss of that material. LOL.
That's crazy view too.
Right.
Okay. But still, let's do it.
Yeah. Great. Good stuff happening. So yeah, we'll talk. So same time next week, 8 p.m. We'll talk soon. Great again.
Perfect.
Yep. Take care then.
You
Bye-bye.
Bye.
Mm-hmm.